So, hey guys, welcome back to Matthew's Ballistics. Tonight I'm working on some 5.56 testing. And the reason why I'm saying 5.56 is because the Ruger American Ranch over my right shoulder there is chambered in 5.56. And I'm running a Arkin SH4 Gen 2 6 to 24 power scope on it, and a AR Stoner 20 round mag, and a Harris bipod, the 1A2BR bipod, or I believe that's what it's called. So, first of all, I'd just like to say that I really love this rifle. Even running factory ammo in it, whether it's 55 grain FMJs or 62 grain green tips, or even some varmint loads, it pretty much has shot everything great. But one thing I found interesting in all of this is that doing, when it comes to reloading and doing hand loads on this or for this rifle, is that it is chambered in 5.56, and typically when companies chamber their rifles in 5.56, whether it's an AR or a bolt action, and they chamber it in 5.56 instead of 223, the main difference is how much throat length there is. So if you look at the reloading specs for 223 Remington, it states that the maximum OAL, overall cartridge length, is 2.26 inches. But, hang on, I gotta go let the dog in. But anyways, when it comes to loading 5.56, the chamber is actually much further than that. I don't have 5.56 specs for overall length. The main thing with the 5.56 is that see here, these are already some of my test loads that I've been working on, and these bullets are the 80.5 grain full bore target bullets from Berger, and these are seated about 2 thousandths off the lands, so they are really long. This is measuring 2.547 inches. So, yeah, quite a bit longer than what the 223 specification is, but even at that length, it's not actually really sticking, it's not jamming the bullet. It's not, I'm not loading to a jam here where the bullet's actually sticking in the rifling. Basically, it's just barely touching the rifling on the ogive there, barely engaging it. And the reason why this is because 5.56 throats are typically longer. And the reason why they're longer has to do with the types of ammunition that NATO specified. Like, for instance, 5.56 tracer rounds, like I think they're 63 or 64 grain tracer rounds. They don't have this really long, skinny ogive here. They're actually pretty short, but they're really blunt. But the thing is when you seat them, that blunt part, they're so fat at the nose that they engage in that rifling cone, going into the barrel. They engage in the side of that cone. So the longer, really skinny bullets can seat much further out without touching that. And that's the reason why you can run these bullets much longer than they will actually fit in the magazine. And I'll show you what I'm talking about. So here's our mag, and this is pretty much a standard 5.56 mag. And you can see right there that we're quite a bit too long to actually fit in the mag, but it chambers in the rifle perfectly fine. So that's just something to think about. But for precision shooting, long range shooting purposes, or getting maximum performance out of your cartridge in a very short barreled rifle like this one, um, being able to seat the bullet out that far means that we can actually lower the chamber pressures with standard loadings, and based on book data, and we can actually seating the bullet out a little bit further would allow us, it would lower the chamber pressure a little bit, so that would actually allow us to add a little more powder to the charge and actually maybe increase the velocity a little bit higher than what you would normally find in book data. And going along with that, because I'm using such a heavy bullet in a short barrel, I want to try to maximize the amount of velocity that I can get, and therefore maximize the amount of range I get out of it. So, what I've decided to do is I'm testing some Hodgdon's LeverEvolution or LeverEvolution powder. And this is, a couple steps above, or, like if you're looking at a burn rate chart of all the powders, all the major powders out there, the LeverEvolution sits a couple places slower on the chart as far as how fast it burns. It's slower than CFE 223. And I know people use CFE 223 to load even 308 rounds with. I know that there's load data out there for it. So I'm like, when you start thinking about pushing a 30 cal bullet with the same bullet, or with the same powder that you're pushing a 223, and you're running around the same pressure, well, maybe using some LeverEvolution, which is known to run 308s pretty good, as well as some other rounds that are kind of in the same design area, maybe run that little bit slower powder at a little bit higher charge weight will allow us to get a little bit more velocity out of this short barrel without too much pressure. So, and I've done this a lot with powder in the past. I've loaded with powder slower than what they were designed. I've loaded powders in cartridges that the powder on paper is a little slower than what it was designed for, and it's a little outside of the what the recommended powder burn rate range is. So, and I've actually been successful in some areas, being able to get more velocity with less pressure. On the other hand, occasionally some of these powders are a little bulkier than others, and it actually doesn't help out very much. So, like in the case with the 338 Lapua, that whole deal with being able to run the 300 grain bullets at 3,000 feet per second or whatever, that had to do with my chronograph running low on batteries, and it was just reading low, and I didn't know that until the next time I took the chronograph out, and about a quarter way through the session or so of shooting, it popped up a low battery sign. And then when I changed the batteries out, all of a sudden all those velocities that were reading really high started reading lower, like about 300 feet per second lower. So now I'm like, do I need to retest all of everything else that I haven't tested since then? Probably. It'd be a good idea. But now that I know that running 100 grains of powder of H50 BMG in the 338 Lapua, I'm getting about 2730 on the velocity, which, I mean, if I can get it consistent, which it's pretty consistent, is the extreme spread's about 30 feet per second or so, 30 to 40, depending on the other environmental factors. So it's not terrible for a powder that is not really designed for that cartridge. But anyways, that's not what we're here for. We're here to focus on this Ruger American Ranch 5.56, and so I've loaded already. I've done 24 grain tests, or I've loaded for the 24 and 24 and a half. I've got to do 25, 25 and a half, 26 for the Hodgdon's LeverEvolution. And then what's going to be interesting is that I'm going to load the same for another 25 card or casings, but with these, we're going to use the Hornady Neck Turning tool, and I'm also going to use K&M Precision primer pocket uniforming tool and the flash hole uniforming tool from K&M Precision shooting products. So we're going to uniform the flash holes and primer pockets, and also I'm going to add in neck turning the brass. And this is all once fired brass from the same lot. It's all Lake City 11 brass, 2011 brass, and it's all from the same lot. It was bought in bulk or whatever. So I'm going to finish loading these 25 cases, and these are my standard loads. The way I've always loaded 5.56 is I've never really messed with primer pockets or flash holes or anything. I just load them. I mean, most of the time, don't even clean the primer pockets, and they still just shoot good. I mean, I think a lot of the accuracy that you get from 5.56 comes from the lack of recoil, and it's just a really pleasant round to shoot. So you can kind of make a few sacrifices here and there with how much attention to detail you put into loading it, and you can still make a pretty decent round out of it. But I'm going to go above and beyond and do a second set of testing to compare, and those are going to add three extra steps to the reloading process with the uniforming of the primer pockets, the flash holes, and also neck turning them. And we'll see how it goes. So I'm going to get into this, and hope you guys enjoy the show. Alright, guys, so that was about 30 seconds of fun there. Next, I'm going to move on to our test group of brass. I just finished up our control group, and I want to move on to our test group. I got 25 pieces of brass from the same lot, same as those once fired from the same gun. These have already been resized and deprimed. And I'm going to start with actually uniforming primer pockets. So I'll have to find my small primer pocket uniforming tool, which should be right over here somewhere. There we go. Small pocket uniforming tool. And this is a K&M Precision tool. And this is supposed to work for small rifle and small pistol. Now, the one thing I noticed seating the primers into those pieces of brass was that not all of them are perfectly even with the back of the case. Some of them are just ever so slightly recessed. We're talking about like a couple hairs thickness, and some of them are sticking out just a little bit, a couple hairs thickness. So with this primer pocket uniforming tool, it cuts it perfectly straight into the primer pocket, or at least that's the idea. And once this thing that flat machine surface meets the bottom of the case, it stops cutting and you're good to go, and you should feel no resistance at that point. I'm going to go ahead and do these with a drill because that's what I've been doing on my 6.5 brass. So I'm going to go ahead and get into that, and we'll see how it goes. Woohoo! 25 cases and 10 more seconds of fun for you guys. Alright, so on from that, the next part will be flash hole uniforming. And for this, I could take this little handle off and chuck it in a drill and make quick work of this, but really for this part, it just takes a couple turns, just enough to chip the little sharp edges off the flash hole and to uniform it, make it more perfect. And there's, like, it's better to actually feel it so that you can actually stab the flash hole, because trying to do it with the drill is kind of a pain in the butt. Actually, I've tried it both ways, and doing it by hand is actually quicker and easier. Of course, you could probably get used to doing it with the drill, but check out that. That is, see if it'll focus there. That is one clean primer pocket. So, if anything, using the primer pocket uniforming tool, even if it removes just a little bit of material, and occasionally, like some of these primer pockets, it didn't remove very much material at all. It basically just cleaned the carbon out, and for those, they were perfectly depth, the perfect depth. But on some of them, it cleaned out and removed quite a bit of material, and you end up with this super, super clean primer pocket there. So from there, we're going to do the flash hole uniforming, and then I'm going to vacuum up all these little metal shavings off of my bench here, and then I'm going to get out the neck turning tool and try to set it up good. I haven't really used it that much, so it's going to take a little bit of experimenting to get it set right. So let's get to it. I'm going to go ahead and clean these flash holes out, uniform them, because the flash holes are in these cases are actually stamped. They're kind of pressed through, so some of them have really sharp edges, some of them have little extra pieces stuck on there, some of them, they're not perfectly round. So using the flash hole uniforming tool just basically cures all of that. So here we go. Alright guys, so another 15 seconds of work there. I'm telling you, this stuff goes quick. In a couple of minutes you could have like a couple hundred cases done. No problem. You just gotta be really fast, like I was in the previous clip there. So anyways, on a few of these cases, I think 3 out of the 25 I did, there was 3 of them that were noticeably, like, seriously had some crud either built up in that flash hole, or they seriously were not stamped very good or anything, because quite a bit of material had to have been cut out with this little tool. And this thing only cuts a 0.08 inch flash hole, I believe is what it says. So it's actually it's stamped right there. 0.08 inches is the diameter. For and that's the standard flash hole in most cartridges. Now, all this brass supposedly is the same, from the same lot and everything, and there were a couple pieces that were noticeably had way more resistance and needed to remove way more material from them than the next piece, or the majority of them. The majority of them just had a couple burrs that needed to be removed. No problem. No big deal. Now, whether all these extra steps between the flash hole uniforming and primer pocket uniforming and the neck turning that I'm about to get into, whether those actually make that much of a difference or not, I don't know, because there's a lot of shooters out there that don't even clean their primer pockets. They just re-prime them and keep going. And for the most part, with handgun loads, I do the same thing. I don't even clean the primer pockets with handgun loads. But when I'm trying to get really precise rifle loads, and I'm trying to like shoot quarter minute groups or less, um, I'm basically just doing all this extra stuff as insurance. It's just insurance. It's just eliminating all the variables that I know I can control and that I know I can eliminate. That's really all it comes down to, is just eliminating the control variables. Anything that you can have control over and you can eliminate, you should do it. And I don't shoot competition, but I really want to, and I know a lot of those guys try to eliminate as many of the variables that they can have control over, or that they do have control over. If they've got an option to work on something and fix it, like the flash holes or primer pockets or the neck tension, neck, the wall thickness of the brass at the neck, with how much tension it has on the bullet. If they can manipulate that in any way to their advantage, they're going to learn how to do it. They're going to try to do it, and some of them even succeed in doing it. Now, me, I don't know. I probably don't shoot in that league. I'm probably not quite that good, but I'm trying. So, um, for the most part, I think that, if I can get my equipment as good as I can get it, the rest of it's on me. And if I shoot bad, it's my fault. It's not the equipment's fault, which is the case most of the time anyways. But occasionally occasionally it does come up that I can actually blame something on some of the equipment I was using. So anyways, I'm going to load or get out our neck turning tool after I vacuum up all this extra metal here. Actually, I may not do that because I'm going to have to clean it up again anyways after I neck turn everything. So I'm going to get that out. I'm going to try to get it set up right. From what I understand, when you're setting up the neck turning tool, is you want to set it up in a way that it doesn't quite contact right there, like the seam between the neck and the shoulder right here. You basically want it to be there, but you don't want to be in it. You know what I mean? Because you can accidentally get the brass a little too thin there, and then that may, it's going to cause some issues. It can cause some serious issues at the range, if you end up getting a case stuck in your rifle and part of it breaks off in there, and, it may ruin your shooting session. So I'm going to try to get this thing set right, and I'm just going to take off enough material that all the case necks look the same. That's the goal, is that it just takes off enough material. Like if one of them has a thinner case neck than another, I basically want to make sure they're all the same, brought down to that level of the thinner case neck. That way there's less thickness of material, less tension on the bullet, basically more uniform tension on the bullet. That is the goal. And all these little things affect other little things with the internal and external ballistics. So mostly it starts on the internal ballistics here, trying to get as consistent of a velocity as I can, as low as an extreme spread and as low as a standard deviation as I can, and just try to get the barrel harmonics just right with the powder charge. I mean, God, there's so much work that goes into making really good ammunition, and I'm really just now learning how to do it. I've been doing this for a couple of years, precision rifle reloading, but I'm really at this point just really starting to actually grasp the concept of how these things actually work. So before, loading pistol round straight wall cartridges, way easier than bottleneck cartridges. That I would recommend everybody start with straight wall cartridges before they get into bottleneck, just because there's you know, it's just so much easier to load. There's so much more forgiving if you make a small mistake, you know, and that's just how it is. So, to get into this, I'm going to grab this tool right here. Grab that guy. Actually, a piece of it just fell off there. Yeah. Move that out of the way. Alright. It's the most interesting thing. I just think it's kind of cool how they put this whole thing together. It's kind of interesting. But, anyways, I want to remove this. And I'm going to go ahead and remove this mandrel because this is a 6.5 mandrel. Grab the bag here. Obviously the small one in here is the 22 cal mandrel. So it goes 22, 243, 264, and then I believe 308, and then of course I bought a 338 mandrel to go with it. Because they don't come with a 338 mandrel. And then it comes with a little extra cutting bit too as well. So basically you thread this into the back of here. If I can get it straight. Make sure, yeah, that's the 22 cal. And from here you can kind of look and tell that that cutting edge is way too far down on the shoulder there. So turn it in just a little bit. And we're going to bring that cutter down. Turn it in a little more. I think right in there is probably going to be where the good spot's at. So screw this into the back of it and just kind of hand tighten it. Doesn't have to be super tight. From here, get my Hornady shell holder because, by the way, using this tool, no other shell holder will work for you. It's got to be the Hornady. So I said that, and I'm literally using a Lee shell holder. So, sorry guys, hang on just a second. I'll find the Hornady one and we're going to get into it. Alright, so I kind of almost skipped over one vitally important step, and that's one of the steps in the normal procedure for reloading, and that is trimming the brass. I was kind of having a little bit of an issue setting up the neck turning tool, and that's because I forgot to trim and then transfer and deburr the brass, and so I was having some inconsistencies in getting the tool set up. So I went ahead and trimmed everything, and I started with the case that I already somewhat did a little bit of neck turning on. This will be in the first group of 5 to shoot, so it'll be important to note that this is the one that I kind of screwed up just a little bit. The following 20 of them, the following 4 sets of 5 will be uniformly made, and much better, hopefully. So go ahead and do my chamfer and deburr. And the way I do this, I do it with the hand tool, and basically I go forward once, back once, forward once, and back once. And then it's done. And then forward, back. That's it. Um, I've seen a couple videos of people with those automatic chamfer and deburr tools, and they like hold it on there like zzz, 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 and and they don't realize that their trim length, they're actually taking it past their trim length a lot of times. So it's the reason why I prefer to do this by hand, and I do it exactly the same on every case every time, and I'm not really putting that much pressure on it. And those guys using those machines, they really don't realize that from one case to another, they may be pushing more or less pressure on there, and then they may be holding it on there more or less time. This for me is more of a distance thing, as I just go forward as far as I turn, back, forward, back, flip it, forward, back, and it's done. I don't need to go any more than that. All it is taking the little rough edges off inside and out of the case. There's no need, like, you're not trying to bevel the case for stuffing, like you would with 454 Casull or something, where you're actually needing to expand the mouth to fit that big fat bullet in there, and then crimp the bullet, and then you come back and recrimp it into the bullet. So this is not that with rifle ammunition. All your chamfer and deburr tool is to just take that sharp edge off so it doesn't cut into the jacket and doesn't hang up in the chamber of your rifle. So yeah, I mean, there's not much to it. Just a 1 2 1 2, 1 2 1 2. That's it. That's all there is to it. It's done. There's no need to sit there and go, oh, 1 2 3 4, 1 2 3 4, and then like a lot of times you may be taking off way more material than you think you are, especially with those automatic setups. They can take off quite a bit of material in a very short amount of time, and you may not realize it. So maybe something to look into if you're having accuracy issues. I would suggest looking into that. So anyways, I'm going to get into this. I've got a chamfer and deburr the rest of these now that I've trimmed them properly. So hang on, bear with me. We're going to get into the neck turner here in just a second. Alright, now we're going to get on to neck turning. Okay, now that I've fixed all my inconsistent points there. So now I'm going to take this first case that I kind of already started the neck on, and then realized it started getting into the shoulder a little more than I wanted. I mean, we're talking just by hair, so it's going to be fine, but I'm going to have to pay really close attention setting up this tool. So here we go. Alright, so with the way that I've got this thing set up, is I'm taking off about 1.5 10 thousandths, so about 1,000th, give or take, plus, minus a half, so 1.5 10 thousandths of an inch. So this one measures 0.0105. That is one of the trimmed cases. And if I take one that I didn't do yet, it measures measures 0.0125. So I've actually taken off about 2/10,000ths of an inch, give or take. But if I grab another one of the ones that I've already done, they measure exactly the same every time. So this is kind of one of those deals where it's like, oh, this one measures 0.0125. This one measures 0.0135. This one measures 0.0125. So they can be off by as much as a thousandth of an inch, but doing all of them exactly the same, they are exactly the same within 1/10,000th or within 5/10,000ths of an inch. So with better than 1/1000th of an inch, but about the tolerance is about 5/10,000ths of an inch. So that's one thing to keep in mind doing this, and that's the reason I'm doing it. I don't have it mounted to my table, but I'm using the drill, and so far so good. Let's keep rolling. All right, guys. I know it's getting late. Goodness gracious, what time is it? It's 9:50, so it's not too late, but it's getting there. Finished neck turning the brass, so if you wanna, well, I actually don't have a piece. I've got some loaded bullets that aren't neck turned, so you can kind of look at that. These are Alco bullets, which are fly really good too. But yeah, the neck turned brass is just a little different. All it is basically you thin down the wall of the brass that or the part of the wall of the brass that holds on to the bullet, and we get it all a little thinner, a little closer to the same, and the goal is the neck tension's more consistent on each bullet. So just grabbing a couple random ones, and they're all within about half of 1/1000th of an inch. So they are all within 5/10,000ths of an inch of each other. So that's pretty good. Now we're going to get on to, I'm going to go ahead and prime these and then powder them and seat the bullets in them. Alright, so now comes time for seating these bullets, and I did not adjust my seating die. I left it where it was set for the other bullets. So look at that. I left it exactly the way it was set. Let's see how this feels. Okay. Seemed really light neck tension there. Okay. I left it set exactly the same as I did with the other ones that I did not turn the necks on. So let's measure these first 5 here in just a second. Because there's like a very slight initial resistance, and then they kind of just glide into the case mouth with pretty much the exact same resistance all the way until the shell holder meets the bottom of the die. So keep in mind, bullet OAL is different from bullet to bullet. So let's see what we got here. We're at 2.543, 2.541, 2.539, 2.546, and 2.543. So let's grab the first of the other ones and let's measure those. 2.545, 2.541, 2.547, 2.540, and 2.544. So maybe a little bit of a difference. I don't really know. The real result is going to be when I go and fire these. Based on the feel of them, they felt exactly the same, every single one of them. On these other ones, I didn't quite get that same feeling loading those, and I never have had that same feeling. I mean, this is the first time I've actually done a series of neck turn brass, and the feeling or sensation of seeing the bullet is it's a lot different. After loading a lot of ammunition on a single stage press, one at a time, this is noticeably different a feel, and it feels like it's a higher quality of feel. Like it's more even, there's no dragging, there's no like hard spots and soft spots. It's perfectly the same pressure all the way down. So yeah, I really think that may mean a difference out on the range, but the targets don't lie. So we'll have to go out and we'll shoot and we'll see what the targets say. So I'm going to get back into seating these bullets, and then I'll give you guys a once over and a picture of all of these. Alright, so I finished bullet seating those, and just for fun, let's go ahead and check a few more of them. We're going to check the group that is 25.5 grains. Let's go ahead and check those for OAL. We got 5.535, 5.541, 5.541, 5.538, and 5.551. So I guess the O jive's a little different on a few of these. So we're going to do the 25.5 grain group here. We got 5.548, 5.541, 5.544, 5.548, 5.541. So it's up to you, but I really think that the neck turned group ended up with a little bit more consistency. Maybe not that much more, but I think it's just a tad bit more consistent in bullet seating depth. Of course, from bullet to bullet, each one of these, the way the bullet seating die seats the bullet is off the ogive, it's not off the tip, and the very tip of these can change in length just a little bit. I mean, you know, a couple hundredths, or sorry, not hundredths, but a couple thousandths of an inch is not abnormal, and well within acceptable range. And the overall weight on all these bullets are, I mean, it's really not even really a measurable difference with the Bergers. So the real results will be when we take these to the range and we really get to see how they do. So I haven't decided how I'm going to shoot these yet at the range. If I'm going back to back with you know, like shoot the 24 grain group with the control group, and then shoot the 24 grain group with the test group with all the extra work, or just shoot all of the groups, all of the ones of the control group, and record the data, and then shoot all the ones of the test group and record the data. I'm not sure. I'm kind of leaning towards alternating and shooting the 5-shot group from the control group at one cartridge weight, or one charge weight, and then shooting the 5-shot group from the test group at one, you know, at one charge rate, at the same charge weight, and comparing the results while the barrel cools. I think that may be the way to go, versus shooting all of one and then all of the other, because at that point, you know, the copper fouling is going to build up in the barrel, carbon build up and everything. It's dynamically going to change throughout the testing of these bullets. You know, we've got a total of 50 rounds to test here, and the dynamics inside of the rifle, internal ballistically, are all going to change from bullet to bullet, and the more bullets that go down the barrel, the bigger that change could be. So I'm thinking we'll do the 24 grain of the control group, and then the 24 of the test group, and then the 24.5 of the control group, and 24.5 of the test group, and 25 of the, you know, at the control group, and then 25 grains at, you know, at the test group, and so on till the whole thing's done. And hopefully that will, you know, give us something to look at and something to think about. So anyways, hope y'all had a good time watching this. I know it's a long video, and I apologize for that, but I had a lot to go over, and I had a lot to really kind of talk about, and maybe hopefully, you know, it might turn on a light bulb for some of you guys that may be having trouble. There may be, you know, I might have some ideas that you didn't think of, and you may have some ideas that I didn't think of when it comes to reloading. So if you got some ideas as far as this type of testing goes that you think that I need to know about, please share those in the comment section below. I do read the comments, all of them, and most of the time, actually pretty much every time, I will reply to a comment unless it's kind of dumb or unless I just don't understand. But yes, let me know what you guys think, and please like, share, subscribe, and we'll see you next time in the next video. Thanks for watching.